Hello friends, welcome back to Information Systems. Time to talk about cloud computing and cloud deployment models. Let's start with an overview of cloud computing along with its characteristics. Finally, cloud deployment and service models. Cloud computing is the delivery of computing services including servers, storage, databases, networking, software, analytics, and intelligence over the cloud. Nothing but the internet to offer faster innovation, flexible resources, and economies of scale. As per the National Institute of Standards and Technology, NIST, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. For example, network, server, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. If we ask for a quick example of a cloud computing provider, the first thing you can think of is Google's Gmail. Gmail users can access files and applications hosted by Google via internet from any device. Ultimately, the cloud is just a metaphor for the internet. The term cloud originated from the cloud-like bubble that is commonly used in technical architectural diagrams to represent a system. The system may be internet, a network, or a computer cluster. In cloud computing, a cloud is a collection of IT resources, including hardware and software resources, if we can think of. You can deploy these resources either in a single data center or across multiple geographically dispersed data centers that are connected over the internet. Now, the cloud model is something like you can think of utility services such as electricity, water, and telephone, etc. Typically, users like or they don't really bother how it is being generated, where it is coming from, or how it is managed, right? So if you think in a similar line, cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can just access technology, services such as computing power, storage, and databases as needed basis from a cloud provider like Amazon Web Services or Microsoft Azure. Now, cloud computing provider doesn't mean providing IT resources alone, but rather providing strategic core information technology as a technology partner for your business needs. Let us discuss about the cloud model's essential characteristics. There are about 5 of them. Let's take one by one, right? The first in the list is on-demand self-service. As I mentioned in the previous slide, a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with service provider. Broad networking access, second in the list. Capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thin or thick client platforms, for example, mobile phones, tablets, laptops, and workstations. A very interesting factor in this cloud computing is resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumers' demand. There's a sense of location independence, of course, in that the customer generally has no control, neither any knowledge over exact location of the provider resources, but may be able to specify location at a higher level of abstraction, example, country, state, data center. But in some cases, customers do know because of the compliance reasons or local laws and so on. Examples of resources include storage, processing, memory, and network bandwidth as part of the cloud computing models, right? Another one, very important, rapid elasticity. Capabilities can be elastically provisioned and released, in some cases automatically, right? A lot of automation in place to scale rapidly outward or inward, commensurate with the demand. To the consumer, the capabilities available for provisioning often appears to be unlimited and can be appropriated in any quantity at any time. That's the beauty of the cloud computing, isn't it? Measured service. Ultimately, how do you measure the offerings what cloud service providers gives to the end customer? Something called measured service. Cloud systems automatically control and optimized resources used by leveraging metering capability at some level of abstraction appropriate to the type of service. For example, storage processing, bandwidth, active user accounts. And resource usage can be monitored, of course, right? Controlled and reported, providing transparency for the provider and consumers. Of course, that's one of the very important aspects, right? Transparency. Moving on. Let's talk about some of the cloud service models now. Cloud service models, right? That's what we are going to talk now. First in the list is infrastructure as a service, IaaS. It's basically a virtual provision of computing resources over the cloud. An infrastructure as a service cloud provider can give you the entire range of computing infrastructure, such as storage, server, networking, hardware, alongside maintenance and support. What more you need it, right? Businesses can opt for computing resources of their requirement without the need to install hardware on their premises. Amazon Web Services, Microsoft Azure, Google Compute Engine are some of the leading infrastructure as a service cloud service providers in the market. It is a way to deliver cloud computing infrastructure like server, storage, network, and operating system. The customers can access these resources over cloud computing platform, that is internet, as an on-demand service. In infrastructure as a service, you buy complete resources rather than purchasing servers, softwares, data center space, or network equipment. Infrastructure as a service was earlier called hardware as a service. It's a cloud computing platform based model. What it differs from infrastructure as a service is the way that users have the bare hardware on which they can deploy their own infrastructure using most appropriate softwares. Talking about some of the advantages for this model, users can dynamically choose a CPU, memory, storage configuration according to their need. Users can easily access vast computing power available on infrastructure services cloud platform. Now, when I talk about disadvantages, infrastructure as a service cloud computing platform model is dependent on availability of internet and virtualization services. Moving on, platform as a service or PaaS is essentially a cloud base where you can develop, test, and organize different applications for your business. Implementing PaaS simplifies the process of enterprise software development. The virtual runtime environment provided by Platform as a Service gives a favorable space for developing and testing applications. The entire resources offered in the form of servers, storage, and networking are manageable either by company or a platform provider. Google App Engine and AWS Elastic Beanstalk are two typical examples of platform as a service. Platform as a service also a subscription based that gives you flexible pricing options depending on your business requirements. PaaS, a programming platform for developers. This platform is generated for the programmers to create, test, run, and manage applications. A developer can easily write the application and deploy it directly into a PaaS layer. Platform services gives you the runtime environment for application development and deployment tools. Google's App Engine, Windows Azure, Salesforce.com are the examples of platform as a service. Talking about the advantages of platform as a service, it's easier to develop. Developers can concentrate on the development and innovation without worrying about the infrastructure. Developer only requires a PC and an internet connection to start building applications. Now, disadvantages, if I can think of, one developer can write applications as per platform provided by the vendor, hence moving the application to another platform services vendor is a problem, though it is doable. Now, the last one on the list is software as a service. SaaS is a model that gives quick access to a cloud-based web application. The vendor controls the entire computing stack, by the way, which you can access using a web browser. These applications run on the cloud, and you can use them by a paid license subscription for free with limited access. Now, software as a service does not require any installation or downloads in your existing computer infrastructure. This eliminates the need for installing application on each of your computers, with the maintenance and support taken over by the vendor. Some known examples of software as a service include Google G Suite, Microsoft Office 365, Dropbox, etc. It's popularly known as, by the way, on-demand software. Pretty much a software distribution model wherein the applications are hosted by the cloud service provider and provided to the customer's business over the internet. It's associated with data and software are hosted centrally on the cloud servers across various data centers on the provider's side. Mostly the applications are accessed through a web browser. If you talk about some of the advantages of software as a service, it is easy to buy because the pricing of software as a service is based on monthly or annual fee, and it allows the organization to access business functionalities at a small cost, which is less than licensed application. It needed less hardware because the software is hosted remotely, hence organization do not need to invest in additional hardware. Less maintenance cost is required for software as a service and do not require special softwares or hardware versions. Now, the one disadvantage I can think of is software applications are totally dependent on internet connection. They are not usable without internet connection. Moreover, it's difficult to switch among the software as a service vendors. Now, if we talk about cloud deployment models, a cloud deployment model provides basis for how cloud infrastructure is built, managed, and accessed. Each cloud deployment model may be used by any of the cloud services model like infrastructure service, platform as a service, or software as a service. Now, first in the list is private cloud. Private clouds are only accessible by the companies that own them. Many companies that own public clouds are also offering private cloud solutions. Private clouds may be more suited to companies due to their flexibility. Moreover, there are fewer privacy concerns since the company is in direct control of their data. However, high cost of private cloud systems may take them unsuitable for smaller companies. Next is the public cloud. It's available to general public. These clouds are managed, developed, and administered by companies that offer their services. Some examples you can think of is Microsoft Azure, Google Cloud Platform, and Amazon Web Services. Public clouds allow for high scalability and save money, as users only pay for the services they need and do not need to set up their hardware. However, there may be concerns related to data privacy as public cloud services may experiences outages due to malfunctions or planned maintenance shutdowns and so on. Third on the list is hybrid cloud. As the name suggests, these systems allow for the combination of the best features of all cloud types. It's a combination of two or more cloud types. Given that this is flexible option, the pros and cons depend entirely on the implementation of the cloud system. However, a good implementation may reduce cost, provide reasonable scalability, and improve security. All right. The last on the list is community clouds. Community clouds are similar to private clouds in a way. However, instead of one company owning and using the cloud, several companies own and share the cloud system. This type of cloud allows division of cost among companies, which makes it more accessible than private clouds, and of course safer than public clouds. Still, public clouds remain the cheaper option. The storage and bandwidth capacity will be limited due to resource being shared here. The organizations participating in the community cloud typically share the cost of deploying the cloud and offering cloud services. This enables them to lower the individual investment, as I said before. Finally, to create the best possible solution for their business, today organizations want to choose different public cloud services. To achieve this goal, some organizations have started adopting a multi-cloud approach. This video, in fact, a lengthy one, I agree, but I'm sure the amount of information it gave to you is more appreciable than anything else. Thanks for watching and see you again in the next video talking about big data analytics.